We're going to take a look at developing applications for the XMOS series of microcontrollers using Visual Studio Code and the XC-IDE extension. The first thing we need to do is download the XMOS XTC Toolchain. Go to their website, xmos.ai. Go to the Resources menu and choose Tools. You may need to sign in and create a free account in order to download these tools. If you're targeting XMOS XS2 or later series microcontrollers, you can use XTC Tools version 15. If you're targeting XS1 series microcontrollers or target boards like the XMOS Start Kit, you'll need to use the Tools version 14. We'll just wait a moment for the download to complete. Go ahead and open the file to launch the installer. Be sure to install the USB to JTAG drivers. You'll notice that the installer placed an icon on your desktop, XTC Tools 15 command prompt. Go ahead and open this up. What this is a Windows command prompt with the environment variables and path for the XMOS toolchain already set. This allows us to run the tools directly from any directory. Let's take a look and see what devices the tools detect attached to my computer. I've attached via USB an xCORE 200 Explorer board with an XTAG3 debugger. You can see that the tools detect the debugger, XMOS XTAG3. So far, so good. The next thing we want to do is install Visual Studio Code. We can go to code.visualstudio.com/download. There are a number of different installers for Windows. The user installer installs Visual Studio Code only for the current user. The system installer installs it for all users. Choose the appropriate platform for your computer. Go ahead and open the file to launch the installer. There's a few useful options here, like creating a desktop icon, adding items to the right-click context menu in Windows Explorer. But the most important option, be sure to have it checked, is Add to Path. Go ahead and launch Visual Studio Code. VS Code looks like it launched correctly. We can go ahead and close it for now. One other thing that we can check is to make sure that it launches from the command line. You should be able to launch it by typing code and pressing enter. So far, so good. The next thing we need to download is Git for Windows. You can go to git-scm.com/download/win. Git is a very useful source control tool, very popular, and you'll probably use it with your projects. But we need it specifically for the included build of Bash for Windows. Bash is a terminal that's popular on Unix-like systems, and our Makefiles for the XC-IDE extension work best on Windows with Bash as the shell. There are some differences cross-platform involving things like forward versus backslashes, and for now the easiest thing to do is use the Bash shell. Let's download Git for Windows. Open the file to launch the installer. There's quite a few options that you can choose here. You can put an icon on the desktop. This last option is very useful if you use Windows Terminal, or if you plan to use it in the future. Add a Git Bash profile to Windows Terminal. I think it's nice to use Visual Studio Code as Git's default editor. If you have root CA certificates or intermediate CA certificates from your employer or for some other reason, you might want to use the native Windows Secure Channel library. Otherwise, OpenSSL is fine. If you plan on saving passwords with Git, you can use the Git Credential Manager. Otherwise, I'm just going to choose none for this demonstration. You'll notice there's a new icon on your desktop for the Git Bash shell. This is the familiar Bash shell that you're probably used to on Linux or any Unix-like system. One thing I like to do is to create a folder for my development projects. I'm currently in my home directory, and I'll just create one here. Everything looks fine. To get to your home directory from Windows Explorer, open a File Explorer window, and in the address bar, put %, home path, %. This is your home directory, and you'll see there's a folder called Devel that I just created from the Bash terminal. This is where we'll keep our projects. In order for Visual Studio Code to have access to the XTC Tools environment variables and path, as well as the Bash shell, we need to make some modifications. Open up a File Explorer and go to C drive, probably wherever you installed the XTC Tools. On my computer, it's under C, Program Files x86, scroll down to XMOS, XTC, the version number, and here we have the tools. There's a batch file called setenv.bat. We're going to make a copy of this file, and we're going to paste it right here in the same folder. You'll need administrator permissions to do this. And then let's rename it. Code XTC-15 bash. This is going to be a batch file for launching Visual Studio Code inside the bash shell using the environment and path variables for the XMOS toolchain version 15. We can right-click on this, click Show More Options, and open it with Visual Studio Code to edit. The first thing I'd like to do after all these variables are set is change directories to my home folder. Next, we want to launch the bash shell. Be sure to include this in double quotes. C:/ is fine, program files, /git, /bind, /bash.exe. If you installed it on a different drive, use the appropriate drive letter. Then we need a couple switches, -l, -c, and that's to run the command code. If you'd like to have a bash shell remain open after Visual Studio Code is launched, which can be handy if you run tools from the command line, put a semicolon and type exec bash-i to leave you with an interactive shell. Press Ctrl+S to save and give Visual Studio Code administrator permissions to save in this folder. If you drag this file to your desktop while holding down the Alt key, you can create a shortcut. And I like to rename these shortcuts and remove the word shortcut as well as the file extension. Now we have a shortcut that will launch Visual Studio Code in the environment that we desire. Let's try it again. Much better. We're ready to get started with an overview of the XC-IDE extension. You won't find this extension in the marketplace yet because I haven't published it there. I will in the future. For now, we'll need to download the vsix file. Go to bitbucket.org/kpatterson/xc-IDE. This is where I keep the source code repository for the project. We don't want to download the source code, but if you go to the Downloads menu, there's a compiled vsix file. Choose the latest version and click on the file name to download. Open the folder containing your download. This is the file name that we'll need to browse to in Visual Studio Code. In Visual Studio, in the upper left-hand corner, click the three lines, click File, and then, sorry, that was wrong. From the extension sidebar, in the upper right-hand corner of the extensions pane, there are three small dots. Click the dots and choose Install from vsix. Go to your Downloads folder and choose the vsix file that you just downloaded. Now our extension is installed. There's nothing yet to see. The easiest way to use this extension is to create a workspace that's structured in a certain way. I have a sample workspace already created on bitbucket.org/kpatterson/xc-sample. Again, we don't want to clone the repository with Git because we won't be committing back here. But if you go to Downloads, you can download a zip of the repository that doesn't include the Git tracking information. Open the containing folder and double-click on the zip file. Copy the folder inside. Now let's go to your development folder, wherever you have that. I'm going to right-click on my Devel folder and pin it to the quick access area so that it's always handy. Now, let's paste this folder in here. This is a sample workspace for the XC-IDE extension. We're going to rename it. Let's call it XC-hello-world. Inside, there's a collection of files, which I'll explain in a moment. In Visual Studio Code, there's actually one more extension that we want to install. It's the C/C++ extension by Microsoft. It's the first one on the list. There's another one that has 3 extensions in a pack. We don't want that. Now this extension provides syntax highlighting, code completion, and IntelliSense for C and C++ source files. C and C++ files are supported by the XMOS compiler, as well as .xc files, which are native to the XMOS platform. This extension may prompt you to install a compiler such as MSVC, Microsoft Visual C. You're welcome to do this, and it will provide IntelliSense, but keep in mind that the MSVC toolchain is quite large, over 4 gigabytes. It can take a while to download and install. You don't actually need the compiler installed. You'll just lose certain features of the extension, like IntelliSense, but syntax highlighting should work just fine. Now, let's close Visual Studio Code just to make sure that all our extensions are loaded fresh. We should be able to type code directly from the bash shell and relaunch it. Let's go to the File menu and choose Open Workspace from File. Browse to your development folder, and there's the XC Hello World Workspace folder. You're going to open this file ending in .code-workspace. One important thing to understand is this presence of this .xc-IDE file. It's an empty file, but its presence in the root of your workspace folder automatically activates the XC-IDE extension. And that gives us some additional buttons down here on the status bar. Let's take a look at some of the other files in the workspace. This file represents the workspace itself and contains some settings for the workspace. We don't really need to change anything inside that file. There's also a keybindings.json file, which can set some keyboard shortcuts for the XC-IDE extension, such as run and clean. But unfortunately, Visual Studio Code does not load keybindings from a workspace. You'll have to copy this JSON into the global keybindings file for Visual Studio Code. But it's here to make that easier. There's a git ignore file in case you use Git repositories. This is pre-populated with a lot of common ignore patterns. In XC-IDE workspaces, you can have one or more projects. Each project is contained in a single folder at the root of the workspace. We have one here, and its name is main. Inside main, there's a folder called src, which contains our source code. There's only a single source file, main.c, with a single function that prints hello world through the debugger. There's also a Makefile inside the main project directory. Notice there's another Makefile at the root of the workspace. We'll take a look at that one first. This is the global Makefile, which includes make targets such as all, clean, and a target for each project that you create. In this case, a single project called main. If we were to create additional projects, we would have other folders such as main2 or whatever you want to name your projects. And for the all build target, we'd copy this line and we'd add the additional project here so when you do a make all of your projects are built. If you want to build projects individually, you'd copy these two lines and simply rename the project here and here. These makefiles aren't generated automatically, but I designed them to be as simple to use and easy to understand as I could. Finally, if we had an additional project, we would do under clean pretty much the same thing that we did under all. Put an additional line with your additional project. Inside the project folder, there's a makefile that's specific to this project. In this file, we can set the name of the executable. We also have some opportunities to specify compiler options, linker options, libraries that are specific to this project, include files that are specific to this project, and so forth. In the config folder, there are two .mak files. These are essentially include files for make. Core.mak is where all the magic happens. I'm not going to explain this file, and you should never have to edit it. But if you're curious about how it works, feel free to peruse it. Config.mak is sort of like a global configuration for make. You can specify the compiler here. You can specify compiler and linker options, libraries, and include files that would be common to all of your projects in this workspace. This bind folder is where the compiled executables are placed. Executables for the XMOS platform have a .xe extension. Notice there's another file here, main.xe underscore target.txt. This file specifies the target microcontroller or target board that we will be compiling our executable for. There needs to be a underscore target.txt companion file for every .xe executable that is created. And inside the text file is simply a text identifier for the target chip or board. If you want to know what these identifiers are, you can go to the XMOS toolchain under Program Files x86 and look inside the Targets folder. There's a folder here for every supported target, all of the individual microcontrollers, as well as various target boards that XMOS has released. Just remember, if you're targeting an XS1 series chip or something like the XMOS Start Kit, you'll need to use the developer tools from XMOS version 14. Here's the xCORE 200 Explorer that we're currently targeting. The xCORE AI Explorer is a newer board based on XS3 architecture. Finally, there's a VS Code folder, and this contains various settings that are common to this workspace. They're JSON files that you can explore and edit. Visual Studio Code also makes changes to these files. Let's see if we can compile this application. Now, it doesn't really matter where you are right now. If you hit Control-Shift-B, it should initiate a build of the project, essentially xmake all. You can see that it's gone into the main project, has built and placed the compiled executable in the bind folder. It looks like the build was successful. And if we look in the bind folder, we see main.exe. Remember, these two files are companions. This is the executable, and this specifies the target for the executable. You can have multiple executables, and each one can have its own target. Let's take a look at the buttons down here on the status bar. The JTAG button allows you to choose which device you want to run or flash your executable to. You always have the choice of the simulator, xsim. Let's try that. And let's click the Run button, which is just a quick shortcut to run this executable. We have a message that says, please right-click on a .exe file to set active. Because you can have multiple executables, the extension needs to know which one you want to run. Just go to main.exe, right-click, and choose Set Active. You'll see a confirmation message that it's now set active, as well as a confirmation message of the target platform. Let's try running in the simulator now. It looks like it ran fine. Hello world. I also have an actual target board attached to my computer via USB through an XTAG3 debugger. Let's choose that device, and let's click Run. It looks like it was successful. You can also flash your executable to the flash memory on your target board, or some XMOS microcontrollers have integrated flash memory. Let's try that. It looks like the flash was successful. I'm going to plug in another target board that I have, which is an xCORE.ai Explorer board. After you've connected your target board, click the JTAG menu and choose Refresh. You see now that the new target board is listed, but be careful. This board now has the device identifier that was previously on my XTAG3, so just pay attention. Let's try running this on my xCORE.ai board. We have a message that says the binary does not match the architecture. What we need to do is change the target for this board from xCORE 200 Explorer to xCORE AI Explorer. We'll save the target file, and just to be on the safe side, let's do a xmake clean and then rebuild the project, Command-Shift-B. Or you could simply type xmake. Here we have our binary. Let's set it active and try running it again. It looks like it was successful. The target platform is now xCORE AI Explorer. Let's try flashing our executable to this board. The flash was also successful. I have seen flashes fail occasionally. I don't believe it has anything to do with Visual Studio Code or the XC-IDE extension. But if you have a flash verification failure, you might try power cycling your target device and then flashing again. Now, this is sort of a hello world demonstration, And we've named our workspace folder Hello World, but it would be nice if the whole workspace or the project was also named XC Hello World instead of XC Sample. We're going to start renaming individual portions of this project. First, let's rename the main project. We don't really need to rename the source file. Main.c is a common name for the primary C file in a project. In the Makefile, though, we will change the name of our executable. Save that. Now in the global Makefile, we'll need to change all these instances of main to Hello World. We'll use the built-in search and replace feature. Save that file. If we do a make clean at this install, xmake clean, it should have cleaned the binaries. I'm not sure why it didn't. Perhaps because we renamed it, it doesn't touch binaries that might belong to other projects. But no matter, we can simply delete these directly. But make sure to rename the target companion file to match the new name of your executable. Let's try rebuilding. Everything looks good. The last thing we want to change is the name of the overall workspace. And that's controlled simply by the name of the .code-workspace file. We can rename that. This confuses Visual Studio Code a little bit. All you need to do is go back to your File menu and choose Open Workspace from File and browse to the renamed file. Everybody's happy again. Let's try build. Let's try running on the simulator. We do need to set the active executable whenever the workspace is opened. That's the simulator. Let's try the AI board. It looks like everything's working fine. Now, if you close Visual Studio Code, or even close your shell, it should remember the workspace you had open. And the next time you relaunch it, everything should reopen just where you left off. I hope this makes your development easier for the XMOS platform, and thank you for taking the time to watch this walkthrough video.